Students, welcome to the next module of the chapter surface tension, and in this module we are going to learn about pressure difference on two sides of meniscus. Now before we actually start the module, I need to tell you what is a meniscus. Class, if you observe the diagram carefully, we have a glass plate kept in water. Now if you observe the diagram very carefully, I see that wherever that water is coming into contact with that glass plate, I have a small bend formed. These bends are called as meniscus. If the bend is upwards, it is called as upper meniscus. If the bend is lower, it is called as lower meniscus. And also it is called as concave meniscus or convex meniscus. So, if we talk about, let us say we have a concave meniscus, pressure upper side and pressure lower side are different. If we talk about a convex meniscus, pressure upper side and pressure lower side are again different. If we talk about a plane surface, pressure upper side and pressure. So, let us see what is that pressure difference. We say that the shape of the liquid surface can be of three types. First one is a plane surface, or it will be a concave surface, or it will be a convex surface. I say that. Now, let us see what is the pressure difference on both the sides of the surfaces. Let us consider the very first case. If the surface is concave, something as shown. Now I know that if it is a surface, it is under always tension. Okay. Now because of its tension, it always wants to reduce its own area. And in order to reduce its own area, it is always stretching its own self. Right? So let us say, let T be the tension on the surface acting tangentially. So, let us say that we have 2 points A and B, and the arrows are showing the direction of the tension which is there on that surface. Now, if you do resolution of this tension, it would be T1 in the upward direction and T2 in the horizontal direction. Since I have done the resolution of vector, original vector need not be considered now. So, let it go. Now, if you see, the horizontal component of tension, that is T2, cancels each other's effect. So I have only T1 and that is in the upward direction. So I can say that, and hence there is net upward force in the meniscus. Now class, if there is net upward force in the meniscus actually should keep on moving upward, but that does not happen. That means there is a counter force which is coming inside the downward direction, which is maintaining the meniscus under equilibrium. So I say that there is pressure from upward side which is cancelling the effect of upward force, and hence your meniscus is under equilibrium. So I say that pressure on concave side is more than on convex side. Class, remember this statement. Pressure on concave side is more than on convex side. Now, if your surface is a convex surface, something as shown, again I say that let T be the tension on the surface which is acting tangentially in order to reduce its own area. Again, if I do the resolution of vector, it would be T1 in the downward direction and T2 in the horizontal direction. Again I say that T2 cancels each other's effect and we have net force which is T1, which is only acting in the downward direction. So I say that I have net downward force on the meniscus. Now class, if I have net downward force in the meniscus actually should keep on moving in the downward direction, but that does not happen. That means there is one more force which is in the upward direction which is cancelling the effect of this force. Right? So I say that there is pressure coming from downward side. But if it is coming from downward side, from this side it is again a concave side. So I say that again pressure on concave side is more than on convex side. Now class, in the previous case I had a concave surface and pressure here is more. That means pressure on concave side is more. This time I have a convex surface and again I have pressure here more, that is again on concave side. So does that mean that irrespective of what the shape is, pressure is always more on concave side? Right? Now, let us go to the next case, that is, if your surface is a plane surface, again I say that the forces due to surface tension acting on the two sides of the element AB are equal, because this time the tangent on the surface would be this and this. Both the tension are equal in magnitude, opposite in direction, and hence there is no net force and hence there is no resultant pressure. So if you talk about a plane surface, I can say that there is no pressure difference if your surface is plane. So to summarize the entire module, I can say that if your surface is a concave surface, pressure in concave is more. If your surface is a convex surface, still the pressure in concave is more, and if it is a flat surface, there is no pressure difference. I hope you have understood the module class. See you in the next module. Thank you.